Hey, welcome back. Now let's solve the question identical trees. So I don't think the question can be any more straightforward. You are given two trees and you have to tell if they are identical or not. And yeah, this is very easy to do, and we can do it in recursive and iterative way. And let me show both the ways. So first we'll do my favorite, which is iterative way. So what we can do is we can have two queues or two stacks or anything you want, and it depends on what kind of traversal you want to do. My favorite is level order traffic, so I'll do that. So we just traverse both the trees level in a level order fashion, and by at any chance if what you tell level one dot the node dot data node one dot data does not become equal to node two dot data, then we will return false or it will return true. Yeah, it is that simple. So again, this is pretty standard level ordered items. Q1 is a DQ of root 1 and the Q2 will be a DQ of root 2. What do we do? While Q1 and Q2 exists, if at any chance the length of does not becomes equal to the length of, that means that there was some extra node which we added, so we will return false. Also what we do for in range, it does not matter which you want to go, because by now it will be validated that Q1 and Q2 will have the same length. Yeah, we'll do Q1. So what we'll do, we'll pop out the nodes. Yeah, do this. Okay. I don't know why I can't type today. And yeah, we'll do the same for the other node also. And again, then it should be Q2. Don't do Q1. It will lead to, it is a very big blunder. And if so, now let us do the false condition. So if node 1 dot data is not equal to node 2 dot data, that means that obviously they are not equal trees. So we'll return false. And now there are four conditions which you have to check. So if node 1 dot left exists but there is no, if the node 1 dot left exists but there is no node 2 dot left, or the same thing but node 1 dot right exists and there is no node 2 dot right. Yeah, this is one condition which will return false. And we have to do the same for the node 2 also. So if node 2 dot left exists but node 1 dot left does not exist, or node 2 dot right exists and node 1 dot right does not exist, that again means that there was an extra node which you don't want, so return false. Or else what we'll do, if node 1 dot left exists, then, and again the same thing for node 2, and then it should be Q2, and again the same thing for right now. Yeah, and yeah, after all these things, if nothing happened, that means our two traces are identical, so we'll return true. Let me just let's just compile and run it once. And yeah, it's working, so let's just submit it. And yeah, it works. So that was the recursive way to do it. Now let's do it. That was the iterative way to do it. Now let's do it recursively. Doing recursively is very simple. So what we'll do is that we'll traverse each node in a recursive manner and check if the current node is equal to the current node of the tree you're traversing is equal to the current node of the other tree. So we'll just define recursion over here, which will have three values: self and the node one and node two. And if not node one, yeah, if there is no node one and there is no node two, that means we reach at the end of the tree. That means we'll obviously return true. But by any chance, if node one exists but node 2 does not exist, or node 1 does not exist and node 2 exists, so that means that we'll return false. So yeah, imagine this tree was not there, that at that time we have to return false. So now what we have to do? We have to do the checkings. So what we will do? We will check if the node one dot data is not equal to the node 2 dot data. That means that we will return false. Or else what we have to do? We have to return the what do you call the values returned from recursively travel in the left and right sector. So we'll recursively travel it once. This should return true, and the same for right should also return true. We have to have self over here because we are using it inside a class, and the same should return true for node 1 and node 2 dot right also. Yeah. So now what we can do is we can directly return the self dot of root 1 and root 2, and yeah, this is all it for recursive way. This is like super straightforward, and let's just submit it. And yeah, it works, and that's all what matters. And yeah, that's all for it, and thank you for watching till now, and goodbye. And more DSA, I know you can do it, and sayonara.